All right, hey, it's Horner, and this is the first problem. So here we've got that baseball thrown, and the thing that you need to do is think about the speed at 0 seconds, at the top at 5 seconds, and then at 10 seconds. So remember, half the time is up, half the time is down, and your speed in the x here is constant. So, whatever number that would be, it would stay the same. So if it was 10 or 12 meters per second, it's still that. And it's still 12 meters per second. So speed in the x is constant. Because it's constant, that means that for b, your acceleration in the x is 0. Let's think about the speed going up at the very beginning. So at the very beginning, when they throw it at that angle, remember your speed up is large. At the top, the speed up or down is 0. And then as it comes back down, it increases speed up and down. So now it's very negative and very large. Knowing those things, what we can do is to find the graphs that work, we have to remember that our speed is constant and it's positive and there's no acceleration. So for the first one, letter A is letter A. For letter B, no acceleration versus time would be this one. For letter C, it says vertical velocity versus time. And remember, we said that that was really big going up, so very positive, 0 at the top, and then very large but negative on the way back down. And the only one that matches that is this one. So you'll notice it's got a very large, if we think of this as velocity versus time, has a very large positive, a 0, and then a very large negative velocity. When we want to think about the vertical acceleration versus time, we know that is just the acceleration in the y direction is gravity, and that's negative 9.8 meters per second squared. So that would be letter B. So this is acceleration versus time, and this is gravity, which is negative 9.8. Remember, this one was horizontal velocity versus time, so this is v in the x. This one was v in the y. And then letter C was your vertical velocity versus time. And so that's this one. So hopefully those are pretty clear. If we go to number 2, we have a couple of different rocks and they're thrown. When they're thrown, remember the time that it takes to fall is dependent on how tall this cliff is. And because the cliff is the same height, they both take the same time to fall, and we just can call that t. If they take the same time to fall, but this one's moving faster, then it's going to go further. So at this point, we know that the velocity of A in the x direction is less than the velocity of B in the x. So the rock B has to go faster. B's going further in the same time as A, so it must be going faster. For letter B, they want to know about the velocity in the y direction. Remember, the velocity in the y at the top is 0, so going up and down doesn't have any speed until it leaves the hand, and then we just think about the speed on the way down. So here and here, the speed on the way down is exactly the same. It's exactly the same here as it is here, but remember, it was getting bigger because they both accelerate due to gravity. So both start at Vy is equal to 0, and they increase at 9.8 negative meters per second per second. For letter C, they wanted to know about the horizontal acceleration. Well, remember, the speed in the x direction never changes. So these are always the same length. And I really will make these a little bit longer so you can see that they do get longer as it falls. So they're the same speed right there in terms of the y direction, but that gets bigger. Finally, the vertical acceleration is always going to be down negative 9.8 because that's just gravity. So those are the same. and they both have an acceleration of negative 9.8. If we go to the next one, which is number 3, we have a hamster running across a bed. And then it jumps off, and when it jumps off, it goes whee, and it comes down and goes on that pillow. They want to know the time it takes for it to go from here across the bed and then come down to the pillow. We know that we've got to find first the time on the bed. Well, they already told us that, so that's pretty easy. The next thing we need to know is the time to fall. And that time to fall is really just the height of the bed equals, remember, the speed at the top in the y direction is 0. The speed in the x direction, remember, we said was 0.5 meters per second. So we'll move that there. And the speed in the y is 0. So speed in the x, just half a meter per second. That means that when it's falling, our time is 0.404. So we know from here down to the pillow, or just the fall time, which is also the time left to right, is 0.404 seconds. So now we just add the 5 and the 0.404, and we get 5.404 seconds. The next thing they wanted us to do was create some graphs. And so here are our graphs of, first thing, the, this is going to be on the bed. This is the horizontal position. On the bed, we know that it is moving at 0.5 meters per second for a time of 5 seconds. So if we think about how far it goes, it's going to go 0.5 meters per second times 5 seconds. It's going to go a total of 2.5 meters across the bed. Then when it goes to the floor, we know that it's going to basically go 0.202 meters. So if I add the 2.5 to the 0.202, we end up with 2.702. So this is really 2.7, and then we'll put in the 0, and then this should be 2 meters, because this is position in meters and it's horizontal. And so now we've got, starting at 0, we're going to go up to 5 seconds. And at that time, we're at 2.5 meters. So that would be right here, 2.5 meters. And then we go another 0.404 seconds, because remember, that's how long it took to fall. And that's another 0.202 meters. So from here to here is 0.202 meters. So I'm going to add the 2, and I end up at 2.702 right here. For the vertical position, we see that when it's on the bed, it's not going to move in the y direction. So we go from 0 to 5 with absolutely no change in position. But then when it goes to the floor, we know it goes negative 0.8 meters. How do we know that it goes that far? Because they told us it is negative 0.8. So when we come back down, we're going to go negative 0.8. So that's down here. And we remember that it's going to start with a small speed and then have a big speed in the negative direction. So we see that now. If we want to do the graphs for the horizontal velocity and the vertical velocity, we know that the horizontal velocity never changes. It's just 0.5 that entire time. But for the vertical velocity, we need to find out what that is when it's falling. So we know the original velocity is 0, so we can cross that guy off and just call it 0. But then we have negative 9.8 times 0.404. So we know its final speed is negative 3.96 seconds. So up to that 5 seconds, it doesn't have any speed in the y direction. But then when it jumps off the bed, it speeds up in that 0.404 seconds. So this would be 5.404 seconds at this point right here. And that is the fall of negative 3.96 and that is your speed. So it increases from 0 to 3.96. For number 4, and this is the last one I got to, so I'll try to do the others in the morning, I have a small ball rolls horizontally, and it comes off the edge of the tabletop. So this one's a nice, somewhat easy question. And they want to know how much time does it spend in the air. So we've already done this one time. So here we're just doing it again. We know that the distance in the y is equal to the original speed in the y plus 1/2 of gravity times time squared. And we can't make gravity here negative, because if we do, we end up with a negative 9.8 in the bottom. So what we'll do is just take 2 times the height, and we know the height, and we're going to divide by gravity. And when we do that, we get 0.49 seconds. So we know that the time that it takes to fall from the top down to the bottom is 0.49 seconds. If we know that the position change in the x direction is 1.52 meters, we can take that distance divided by the time, and it tells us that the speed the instant it leaves the table is 3.10. And I know that's the speed in the x direction right here, but that's also, if you remember, the speed in the x direction everywhere. So 3.10 there. If it's falling down and it's right here, that's also 3.10 meters per second, because in the x direction, that speed never, ever changes. So hopefully those are helpful, and I will finish the others tomorrow morning and try to upload those.